this video is using three rules of rational functions in order to evaluate limits of rational functions. We're going to do a little exploration right now that you'll see. I'm kind of going to guide you through this. Here are, it says evaluate each of the limits below. You may use the calculator if necessary. So if you want to, at this point, to pause the video and just kind of take a look for a moment at each one of those three limits. This guy, this one, and this one. Now remember, this is n being an exponent, anything greater than 0. Please do so at this time, and then come back when you've kind of graphed each one, kind of explored the limit. Hopefully you had an opportunity to use a calculator and maybe graph these, or if you know it by heart, you kind of see that when you extend this limit as x approaches infinity of 1 over x, what happens is this value of x gets very, very large. What happens when you divide 1 by some number getting very, very large? You should see that you're starting to approach 0. Now here we're going towards negative infinity. So the same idea, if you look at the graph of that, of what that looks like, you would have seen that it has a vertical asymptote at 5. But as it's going down toward negative infinity, you should have seen that they are also approaching 0 at this point. So then this last one, we have x to the n. N could be any variable. So any number. So if you think it could be 2, 3, 4, 5, 100. And if you play around with it and look, you can see that as x gets very large to infinity, when you raise it to a power, it's going to get even larger. So 1 over something getting very, very large is going to get smaller and smaller, and the limit will then be 0. So then what I'd like you to do down here is, again, take a look at each of the functions in group 1 and identify the common thread and investigate how it affects the limit as it approaches both infinity and negative infinity. So again, if you would like to investigate each one of these and see what's kind of happening, again, you can pause the video, take a moment, and graph each one, and kind of look at it. Also, try to identify that common thread you see here, this common thread. Which one do they all have in common? Fantastic. All right, so now we're looking at these limits, and I'm going to give you the answer to these limits, and I'm hoping you ended up with the same answers. 3 over 6, which we know can be simplified to 1/2. This one right here is negative 6 over 2. See, to negative 3. And then this one was 1. So I'm hoping that you got those same answers. Maybe you're giving yourself a little pat on the back because that's exactly what you got. Now, do you understand what the common thread is? Did you find out what the common thread is? Now take again a moment again, if you didn't look, and look at those guys, and look at this, and look here. What do you notice? They all have what? The same degree. These both have a degree of 1, degree of 2, degree of 5. So hopefully you can also see the relationship of the limit of where this 3 over 6 came from, and where this negative 6 over 2 came from, and where this 2 over 2 came from. Alright, let's move on to group 2. So again, pause the video for a moment, take a look at each one of them, and try to identify that common thread that each has, and try to find the limit for each one, whether it is with, maybe you're able to do something with direct substitution, or maybe you're graphing it, but again, pause it now, and then come back when you're finished. Hopefully you had an opportunity to look at this, and maybe you've already been able to identify that common thread. If you're looking at the degrees again, look at the degree here. The degree of the numerator appears to be less than the degree of the denominator. Same thing here, and the same thing here. Were you able to find each of the limits? Hopefully you were able to get looking at group 3, if you again are looking at the degree here, it appears that the degree of the numerator is greater than the degree of the denominator. So the numerator is greater than the degree of the denominator. You probably should have seen something a little different when you graphed each of these. Now if you remember from your polynomial long division, what will happen if you divided this numerator into that denominator? You can probably see what would happen, and maybe that might explain the graph a little bit. And you should have gotten something like this when you evaluated each of the limits. So right now you want to kind of formulate a conclusion based on the three groups and try to write your conclusion in a clear, concise way that you might be able to share with the class tomorrow. But try to come up with those conclusions yourself before moving on in the video, because I will unfortunately give it away in a little bit. Now, based on your conclusions that you were able to draw, see if you cannot evaluate each of these limits on your own. If you're able to do that, you should have recognized the limit for that one was that. 3 of